Get started. We have Carlos de la Guardia. He's going to be speaking on patterns for building large pyramid applications. Let's give him a hand.
So hi, I'm going to be talking briefly about the ways we use Pyramid to make more than the small applications that we feature on the tutorials on the page, so that you have an idea how real applications work. One thing we love about Pyramid is that it's a very flexible framework. In fact, that's the thing that I like most about it. You can just use what you need to use. You don't have to learn a lot of stuff up front to be able to get running and create an application. You can create anywhere from one file applications to large thousands of line applications without having to do the things on the same way on each case. So you don't have the case where you have this framework with lots of tools that you're only going to use one, and you don't have the case that you don't have enough tools to get your work done. So it's very good, but since no persistent backend is enforced, you can choose whatever database you want. You can use a NoSQL database. You can use a relational database. You cannot. You probably have some applications where you don't need any database at all. You can choose about 4 or 5 different templating languages, and you could make bindings for your own language. And even if there are no bindings for the language, you could use whatever template language you want, because it's fairly easy to adjust that in a view, just calling the Python code. Of course, you would lose the advantage of the bindings. There are also many pluggable points, extension points, where you can modify your applications. And in general, we're really proud about this. We know when you use Pyramid, you're in control of your application. You can decide anything that goes with your applications, any part of your toolkit that you want to use, you can integrate it with Pyramid. That said, for new users, this can sometimes be a problem, because when they come, they want to be told what to do. There are so many choices. There are so many things that they can pick. That for a new user, especially if he's completely new to web application development, picking just a template language or deciding if he has or not to use SQL Alchemy is sometimes it's too much. They want to create the application and they want it running now. So it would be helpful if they had some sort of guide about what to do, what to pick. And Pyramid makes an effort to get you there. For example, we have scaffolds. We have an SQL Alchemy scaffold, we have a CODB scaffold, and we have a generic scaffold. And those make some decisions for you. They have some file layout. For example, the Alchemy scaffold, it uses SQL Alchemy, so that decision is made. They choose a templating engine, so the scaffold, for example, we use have Chameleon, so that decision is made for you. And we also have a pretty good documentation, and we also like to work on improving it all the time. So most of the choices that you can make are also pretty well documented. If you take the time, if you have the time, you can read the documentation and get all the information and probably make a good decision. Or you can come with that information to the support chat room or something and get more information. Still, there are some third-party packages that make even more decisions for you. But then choosing one of those is one decision again. So Pyramid helps, but still, there are some other factors. The scope of the project that you're doing, it also has an influence. If you're doing a one-off project, a small project, you will use very different tools than if you are doing a large project. And if you are doing a project where you need relational database, you conceivably could use very different tools and even very different parts of Pyramid than if you are using building a content management system where no SQL database would be used. So sometimes knowing how other people do things is helpful. So that's why on the mailing list, on the chat rooms, most people come to ask, hey, do you know which one is better, this or that, this or this? They want to know if someone has already had that decision and had picked something, and sometimes they don't even care why. If you tell them this is the way to do it, they would do it. So knowing how other people work, what other people has done, is good. Here I will present you with some suggestions. They're only suggestions about project layout, some tips for choosing a persistence mechanism, how to assemble your toolkit. We'll briefly mention something that's called traversal, which is part of Pyramid, and whether you would need it or not. View configuration, which is a very, very strong point of Pyramid. Some deployment notes, and a little bit about extensible applications. Some of the things that I'm going to point out come from my experience working as a member of the Carl developer team. Carl is an open source web application that it's used by organizations like Oxfam and OSF all around the world. To coordinate their work and have a community work and mission critical applications inside their companies. Right now, the version that we're running has more than 5,000 users, all of them logged in users, no anonymous access. There are more than 75,000 pages of content and nearly 100,000 lines of code. So some things that I've learned from working on these systems, I'm going to present here. More information about Carl is on that URL. So, quickly, project layout. Pyramid does not enforce any layout. I mean, if you can do a single file application as easily as you can do an application with dozens of packages. So you're pretty much free to do whatever you want. But for small applications to medium-range applications, the scaffolds that Pyramid use are a pretty good suggestion about how you could start if you don't have any clue about how you would do this. So this is the layout that we have on the scaffolds. And you can see it's structured like a distribution for a Python this-to-tils distribution. And it has a package inside that's called My Project. And we usually have a static directory where we will put all static resources, CSS, images, etc. A templates directory where the templates that will be rendering the pages are. And for simple applications like the starting application on the scaffold, a single views file and the init py files are all that is needed to begin working. If your application starts growing, you could start by adding another module, for example, models.py, etc., and you would be structuring that around this simple layout. For bigger projects, what we use is instead of a file, for example, for a single module for views, we create a package, and that has several modules for views depending on their objective. Depending on what you're doing, you could decide on an application-specific area and use a module for each one of those. So we also, since we like to enforce 100% test compliance, we also usually have a test directory. And maybe sometimes inside the views package or the models package, we have another tests package where you have all the tests for that section only. So this is merely a suggestion, but it can serve to get you going. As you saw, we are using the setup PY, setup configure, and all the other this-to-tils stuff there. Many people come to the mailing list and say, why are we using this? This is too complicated for me. I don't like it. Do I have to use it? The answer is no. You don't have to use it. You can you can just run it like we have on the front page of the Pyramid site. There's a single file application, and there's no trace of any of those things there. But that said, you probably want, if you're writing open source or something, you probably want your distributions on the Python package index. And besides, that's the way things are done in the Python world right now. That's what we have. And I say, go for it, go with it. Plus, there are very good people that are working right now on improving the packaging experience in Python. So I think we ought to give them a chance. I think after these sprints, we'll be getting still more improvements in the way packages are handled. So for assembling the toolkit, there are many options. The persistence backend is probably the first option that people want to satisfy. So SQL Alchemy is the one we recommend for relational databases, but you could use any ORM at all. The scaffold that we have gives you SQL Alchemy. You could also do anything from any other ORM like Storm to direct driver connection using one of the many Python drivers available, like PsychoPG, for example. And you, of course, can use MongoDB. And since many Pyramid developers come from long years of SOAP experience, we have also the possibility to use the CODB. If you are using multiple transactional backends, we also suggest you use Pyramid TM, which is a transactional tool that allows you to synchronize the commits from different engines into one single commit. So if anything goes wrong, you can pull them back together at the same time. The key factor here first is what tools are you familiar with, because you probably can work better with the tools that you're familiar with. And the most important question is, how does your data look like? If you have data that fits a relational database perfectly, you should use the relational database. And if you have data that probably is not out for that, you can use something else. I'll have to say a little bit more about that in a minute. There are many templating languages and many form packages that you can use with Pyramid. Those are just a few. And there are also a lot of authentication mechanisms that you can integrate with Pyramid. Starting with Pyramid's own mechanism, which is pretty good and allows you to have fine-grained control of permissions across resources in your web application. You can also, if you are in development, the Pyramid debug toolbar is a great help, so you should install that. It's a toolbar that allows you to see how your application behaves in a number of fronts, including SQL Alchemy queries, the response time of your views, etc. So, of course, you can also do live debugging via the web. So that would be a very important must for you to have. There are two basic mechanisms for URL dispatch and traversal. For finding the views in your application. One is URL dispatch, which is the classic routes-based. You have a pattern, and that pattern matches, then the view is used. And that's pretty good generally for table-like data. And we have another one that is not as well known, that comes from that world of the C word that I don't want to mention again. And it's called traversal. It allows you to create a tree of resources. You can think of it as a file system. And you can traverse from the root of the file system to some other resource. And you can, in this way, the URL specifies like the path that you go through on the file system. Traversal is very, very useful if you have a tree-like structure in your site, because it's built precisely for that. And modeling tree structures in relational databases is possible, but it's not as transparent as this would be. You just use it and it's done. And it's also very good if the site's content is going to grow directed by your users. You don't know if the user is going to create a new blog inside the community that is in the application here, and he will duplicate that blog and have another. How could you have routes that plan for all of that? It's very difficult because you don't know what the user is going to create across the site. He might feel like creating a blog, but maybe he creates another community inside the community and decides to create a blog inside that. So you cannot really do great route planning using that. It can be done, but again, Traversal is a perfect fit for that. And also, if you need to have granular security, for example, Joe has access to this specific file as opposed to Joe has access to edit files. If you want the capability to say Joe can only edit this one file, then Traversal is a choice for you. I'm not going to explain how it works here, but I just want you to know about this. Pyramid has a very strong view configuration mechanism. And I would suggest, if your application is growing, to use declarative configuration, which is a way to insert a decorator inside, in top of the view that you are writing. That way, you have the configuration right next to the code, and when the code base is very large, it helps to be able to look at the configuration declaration instead of having to find a huge file where all the view configuration is and find which view corresponds to which declaration. So this is a useful mechanism where your view definitions start growing. And one good thing about the decorators is that they don't have any side effects. They do not change the function. They need you to call them from the main initialization of the Pyramid application with a function we know scan. And until that point, it's like the views are not registered. So there are no side effects, which means that you can test your views without fear, even if you use this mechanism. We also encourage you to use renderers. Renderer is a Pyramid mechanism for getting the information that you want from the view to the template. Instead of rendering the template right there on the view, what you pass is just a dictionary, and Pyramid finds the renderer that you configure. In this way, it's very easy to change our templating engine. You just change the renderer in the view configuration. You don't need to mess with the code. And also, it facilitates testing, because you can test that the dictionary that the view returns is something, and you don't have to worry about functional testing to make sure that the view is returning what you want to return. You test first what the view is supposed to return. We also encourage you to use predicates. In Pyramid, you can have a route that can correspond to more than one view. You don't have to define one route per view. The way Pyramid decides which view to call is by the use of predicates. For example, several views can have the route name home, like there. But only one view has the request method post. The other one has the request method get. So that way, when Pyramid finds the route that you're going, the path matches, then it looks at the predicates, and for example, if the method is post, it will go to the form that takes care of the post, and if the method is get, it would get to the routine that shows the actual form. In that way, you can compartmentalize your code very cleanly, have just the code that does some stuff here or there. There are many predicates that you could use. We also have easy HTTP caching. You can add just HTTP cache like that, a number of seconds, and Pyramid will put the appropriate cache control and expires headers in your view. There are many applications that have similar view data that needs to be passed to the renderers. So you can generate that information on every view. There are many alternatives to doing that. You can have, for example, a method or a class. If you need to pass the same 10 values every time, the code gets like 10 more lines for each view. So sometimes it's better to just call a class or a function. Since Pyramid has a view is any callable, you can use a class, you can use a function, or you can even use methods of a class. You could use this to be able to call the same initialization code for a number of different views by using a class. And that class would have an initialization method where all the generic or the common values would be set, and then you could have a different method for it. Yes? Oh, yeah. Sorry, the code is wrong. I didn't put the self in there. Sorry. Thanks, Chris. Well, and I would like to go into this in more depth, but we're almost out of time. Extensibility, Pyramid offers a lot of tools for extensibility. It has a strong extensible configuration mechanism. It can detect conflicts when you are configuring an application and it calls configuration for different places. It can detect any conflicts that are in the configuration and tell you, so that you don't have any surprises or any bugs that are difficult to find because of configuration overrides. It allows you to create structured include statements so that you can call the configuration for other Pyramid application and include it into your own. Let's say you have an application that has several views defined, and you want to use most of those views in your application. You can just include those and then override the ones that you don't want to use or create new ones. And it's all very, very easy to do by just using a config include statement at the beginning of your code. We also have asset specifications, which allow you to refer to a specific resource on the site, for example, a template by package. So you could override a resource from another application within your application by using this asset specification, which is the name of the package and the directory and the name of the resource, or the template. And we also have twins, which are middleware, but Pyramid-specific middleware. And finally, there are some SOAP component architecture overriding mechanisms that I'm sure you don't want to know about. But they are there if for whatever reason you want to use them. I would need 45 minutes actually for this talk, I guess, the next time. I'm running out of time, so I guess this is it. The slides have a little bit more content, but you're welcome to get them from the Python site or ask me for them later. I'm sorry, but we're run out of time. Thank you very much.
Okay, we'll take about 5 minutes for questions.
So the request method predicate is really convenient for doing RESTful APIs, but a lot of modern browsers don't actually do anything other than get and post. You can always write a custom predicate for looking for like an under method field or something like that in form submissions. But are there any plans on adding some kind of a conventional thing to pull out those that kind of like hack that you have to do to do a put or a delete in the normal request method predicate, or is it just going to always be a custom thing?
I don't think I understand the question.
In pylons, if you put in form, you put an under method equal something, it changes the request method. It actually sets the request method to delete something. Then the predicate is request method equal delete. It emulates a delete.
Oh.
Yeah, I don't know if this was something that I should have probably directed at you, Chris, or something.
The answer is no.
Okay.
I can tell you why.
Yeah, sure.
Thanks, Chris.
Thanks for the talk. I was curious about the slide where you were showing the view configuration, the routes stuff, and you're talking about the view decorators being inert, and then there's this scan method. And not being familiar with it, I'm curious if you could talk a little bit more about what exactly that scan method or that scan function does. I'm curious how much you've taken out the magic and how much you've just moved the magic to a different place, if that makes sense.
Yeah. What happens with the decorators is that they are like, you can think of them as flags, that this will be a view. And when the application starts, you can call the scan function from the. You have to create a configurator with Pyramid applications. Once you create a configurator, if you call scan, it will scan the code and find all the decorators there and register them as views.
It'll register derived versions of those functions as the things that we call.
How does it decide what code to scan is, I guess, what I'm wondering.
By default, it scans everything, but you can tell it, you can limit.
Modules, everything? Oh, you give it a package name. Okay, thank you.
Okay, if there
All
are.
right. Thanks,
no
everybody. Let's give Carlos a big round of applause.